Good evening, sir.
Yes, Faika, good evening. How are you doing?
I'm good, sir.
Good. So today we are now going to continue with the revision of this chapter, that is chemical effects. Okay. We'll be starting in just 1 minute. Okay. I will be back.
Okay, sir.
Yes, I'm back. Sorry for keeping you guys waiting. Okay. So today we are going to continue with the revision of a new chapter, that is chemical effects of electric current. How's everyone? Hope everyone doing fine. Yes, Ramesh, Vaika, and Ibrahim. What's
Yes,
going
sir.
on?
I'm doing good.
Good. Okay. So as we know that electric current is basically the flow of electrons, the flow of charged particles through a given conducting material, right? Isn't it? And when electric current flows through a given conducting material, so it is going to produce some effects, right? It is going to produce some effects. For example, if this is a current carrying wire in my hand in which current is flowing, suppose, if I were to bring a magnetic compass near to this, so the needle of the compass will start to show some deflection, right? It will start to show some deflection. Then, if suppose this wire, suppose it is made up of tungsten, or it is made up of some other material, let us say it is made up of chromium, okay, or some other material, suppose, and if current were to pass through that material, so it will produce high amount of heat, right? So heating effect is also given of when current passes through a given conducting material, right? Especially if that material has high amount of resistance, it opposes the flow of electric current through it. So you guys already know about the chemical effect, about the heating effect and the magnetic effect, right? You already know about that. In this chapter, in the revision of this chapter, we'll be particularly learning about the chemical effect. Now, when chemical effect will be given off, like what does it mean? There must be some chemical reactions now. In the 7th grade, you must have learned about the physical and chemical changes. You must have learned that. All of you, turn your cameras on. Yes, all of you. Yes, Vaika, you also. Yes. Now, in a chemical change, what happens? We see a chemical change has occurred whenever some chemical reactions takes place. Whenever some chemical reactions takes place. whenever a new product is obtained. So a chemical reaction is said to have happened, right? Like for example, you take two substances A and B, both of them reacts to form a new substance C. It can form one more product, let's say D, or many more products. So thereby a new substance has been formed. Okay, no issue, Aika. Also, let's say you have taken a piece of paper, you are burning it. So the paper reacts with the oxygen to form ashes. So it's a chemical change. A chemical reaction has occurred and a new substance has formed, right? So when electric current would be passed through certain materials, so there also some chemical reaction must happen now. There should be creation of new substances, isn't it? So that's the
Yes,
basis of chemical effect, that when electric current will pass through a given material, so it will lead to some chemical reactions. A very simple example can be taken, that of a water, particularly a acid water that contains acid or any other impurities in it. So when electric current is made to pass through this, the water splits up. A chemical reaction happens and it splits up into oxygen and hydrogen, which are its components. So it splits up into its components. Getting it, everyone?
yeah,
So that is the case. So in the chapter, first we will learn a little bit about the electric current. Are you guys able to view this or not?
yes, sir.
So we'll be learning a little bit about the electric current, like what is the basis of electric current, conductors and insulators. Okay. Then how we can test the conductivity of a given material. How, like, if it is a good conductor or bad conductor, how can you check for that? Then we will be learning about electrolytes. Okay, what are the electrolytes? Then what are the chemical effects of electric current particularly? Okay, and some of its examples. Then we will learn about applications of the chemical effects of electric current, then how we can check for the water for its purity. Okay, like if water is pure, no, it will not conduct the electricity. But if it is impure, then it will conduct the electricity. And we can take the help of LEDs to check the conductivity of a given liquid. Okay, and we will learn that why only LED and not incandescent or other bulbs. Then we will learn about electrolysis. That is basically a process that will be used to split up a given compound into its components, specifically cations and anions. Okay, then in this we'll be revising about the electrodes and the electrolyte and all that. And what are the safety precautions one has to take care of while handling the electrical appliances. Okay, I want all of you to observe this given animation first. Like what is happening here? One thing is obvious, that we know that every matter that we see around us is made up of, everything that we see around us is made up of atoms, right? We ourselves are made up of atoms, right? Further, atoms contains some subatomic particles inside it. Like an atom contains protons, electrons, and neutrons in it. Say that this is a piece of iron rod, and this will be made up of uncountable number of atoms in it, right? Suppose we have taken one atom out of this. How the atom of this iron will look like? We are giving it a representation like this. This will be the nucleus, and this is the orbit in which particles like electrons are revolving. That's where the electron would be there. And this is the nucleus, and for nucleus. And in this you have got and electrons. You have got electrons. So what is basically happening? The electrons are flowing. How it is flowing, I have got another animation. Take a look at this from a different slide, by the way. 1 minute. You guys just take a look at for this for a moment. See, the green ones, all of you pay attention here. Ibrahim, Ramiz, and everyone. See, the electrons are moving from one atom to another. You all can observe that the green dot here, the green balls are representing the electrons, and how it is moving inside this current carrying wire. Suppose this is a conducting wire, like suppose it's a copper. And all these are the atoms of copper. So what are these structures? These are atoms. And what is moving here? The electrons.
Electron.
Electrons, okay. So electric current is simply the flow of electrons in this given conducting wire. For example, you have copper. So got the concept of what is electric current, how it is generated?
Yes,
Got
sir.
it?
Yeah.
So that's the basic thing about the electric current and how it is generated. Then question is like, how do we measure the electric current? Like, just like you have to measure the weight of something, you need to have some weighing scale, right? So in order to measure this also, we need to have some instruments, some appliances should be there. So we have got the ammeter, okay, no? So electric current is flow of electrons through a conducting material like a metal wire. For example, you have copper, you have silver, aluminum, etc. Which one is the best conductor of electric current out of all the metals? I might have told
Copper.
this several times. No, it isn't copper. Although copper is used,
So what is the question?
question is which is the best conductor of electricity?
Aluminum.
No,
Silver or
Iron.
it's a iron is no, it's a very poor conductor. Okay, no? Silver out of all the metals is the best conductor. Okay, silver is the best conductor of electricity. All right, Vaika and everyone. Okay, that is the case.
Yes,
Out of
sir.
all the metals. Okay, and how many metals do we have? Any idea? There are total of 94 metals. So out of all the 94 metals, silver is the best conductor. Anyways, now how do we measure electricity? Like how much of current is passing through a given wire? How do we measure it? Have you gone to the physics lab, anyone in your school?
yeah.
So there you
Yes,
must
sir.
have seen an ammeter, a black instrument like this. It will be having a meter on it. Somewhere A would be written like this. You might have seen this, I suppose. So that is called as ammeter. So using an ammeter, the magnitude of electric current is measured. Okay, like how much of current is passing through a given wire. So using an ammeter, the strength of current is measured. Now to measure something, we need to have a unit. To measure the mass of an object, you need to have some unit like the pound, like kilogram. To measure the weight of a given object, you have the unit, right? To measure the volume, you have a unit. Similarly, to measure the electric current, we have got a unit. So unit in which electric current is measured, it is called as ampere. Ampere, and in short, it is written as capital A. So this is some of the general thing about electric current. Hope this much should be clear to everyone. Any questions? Any confusions?
Also.
Good. Next, you have conductors and insulators. So you all know about this. I don't need to define this. You guys define what is conductor.
Conductor is a substance that can that allows electricity to pass through.
That allows electricity to pass through it. And what are insulators? Why can you explain?
The materials which do not allow electric current to pass through.
Right. So those are insulators. Good. So allows current, electric current, or can we say that they will allow electrons to pass through it? Because electric current is simply the flow of electrons now, right or no? So it
Yeah.
allows electric current or simply electrons to pass through. Can you quote some examples of conductors? Yes, Ibrahim, Waika, and Ramesh. Quote some examples. Generally, the metals,
Aluminum,
aluminum,
copper,
Silver.
Copper, silver, which is the best one, right? And many more, right? No? Okay. You guys tell me that can we use sodium as a conducting wire? Sodium. Although sodium is a good conductor of electricity. Okay, no, but can we use it in the form of wires? Also,
I
you guys,
don't think so.
no. Why? Because sodium, you can literally cut it with a knife. It's a very soft metal. Have you seen those experiment videos where some guy would be taking pieces of sodium and he will throw it into the water? And when the sodium will be thrown into the water, it will result into an explosive reaction. It will be a little bit of explosion. Getting it? Yeah. So though sodium is a good conductor, but it is a soft metal. So hence we cannot use it. So it's not like all the metals will be conductors, but generally metals are only the conductors. Non-metals are not the good conductors. There also we have some exceptions, by the way. So here we see that generally metals are conductors. Metals are conductors. Okay, now metals, you guys understand now? Metals are basically substances, the element that are strong, that are tensile, that are malleable, that are sonorous in nature. Getting it? Okay. We have some exceptions like sodium, although good conductor, but cannot be used as wire since it is soft. Now, question is why a certain material will be behaving as a conductor and like for example copper wire behaves as a conductor while some of them does not behaves like a conductor, like a wood is not a conductor. So the thing is that take a look at this structure over here. Like this is a small section out of the copper wire. Suppose these are the atoms of the copper wire, and the smaller balls that you see here, the one in the blue color, they are representing the electrons. They are the electrons. Okay. Also, you should know in general that electrons are negatively charged particles. They have negative charges on them. Okay, now. So what is happening? The electrons in this copper wire are not fixed at certain positions. They are delocalized, they are free to move. They can freely move from one atom to another. As you guys have taken a look at this animation earlier, in which you saw the electrons were basically moving from one atom to another. It was jumping from one atom to another. But suppose if those electrons were to assign a fixed position, will they be able to move freely from one atom to another? Suppose I were to fix these electrons at certain places that you cannot move. So they won't be able to move throughout the given substance and electricity will not be conducted through it now.
Yeah.
But in the case of metals, those electrons are free to move. They can go wherever they want. So that is the main reason. Got it, everyone?
Yeah.
Yes.
Okay. So that is the case. So the main reason that is that the electrons are delocalized or basically they are having free electrons in the conductors. Now coming back to this insulator, so they will not allow electrons to flow this. So they will simply not allow the passage of electricity through it. So materials that does not allow electric current or basically electrons to pass through it. Pass through it. What are some of the examples? Is Harim, how are you?
I'm fine. How are you?
Yes, I'm also good. Okay, so what are some examples, guys? Yeah.
Water.
Water, pure or impure?
Pure.
Pure water. So you have distilled water with
Rubber.
rubber,
Wood.
then wood,
Plastic.
plastic, right?
Paper.
paper, okay, paper, and any other examples of insulators? What about sand, glass, right? Isn't it? So you have got sand, glass, right, etc. So these are some of the examples of insulators. Now again the question comes like, why certain materials are behaving as insulator? So the electrons in them will not be able to move freely. Since conduction of electricity is all about the movement of the electrons, so electrons are not able to freely move in the insulators. Hence, they are insulators. Got it, everyone? So important point to be noted down here is that electrons are fixed and hence not free to move. And thereby electricity will not be passing through it. That is one thing. Okay. Now there are some materials that will allow little flow of electricity. So they will be called as poor conductors. We are neither calling them as insulators, neither we will be calling them as conductors. Since they will allow a little flow of electric current through it, so thereby they will be called as poor conductors. Okay, getting it? While some materials will allow the complete flow of electricity through them, and they will be called as good conductors of electricity, isn't it? That is the case. For instance, let us say you have the wet wood. The wood that is wet, it has some water in it. So since it has some water in it, it will allow the flow of electricity through it. Electricity will flow through it. But will you call it as a good conductor? No. Question was, no? If the wood is wet, you have the wet wood. Okay. So it will allow some flow of electric current through it. So thereby we will call that as a poor conductor. Although wood is an insulator now, but it's wet, it has water in it, so thereby it will allow little flow of electric current through it. So in the similar manner, we see that although air we say that air is a bad conductor of electricity. Why? Because it will still allow electric current to pass through it. It will still allow electricity to pass through it. What happens when too much of charges accumulates on the cloud? So the air will be forced to conduct those charges onto the ground, onto the surface of the earth. And the too much of charges will be accumulating on the cloud. So what happens? Those charges will force down the air. Basically, the air will be forced down to conduct those charges onto the surface. So the basis of this discussion is that we should not be classifying a given material as an insulator and a conductor, but generally we classify the materials, and in fact always the materials are classified as good and poor conductors of electricity rather than conductors and insulators. Got it, everyone?
Yeah.
Yes, sir.
Okay, we have some general examples. Okay, these are some of the general examples. Then getting back to the next topic, that is the electrolytes. Okay, in this first we'll learn about the conduction of electricity through the liquids. Generally, so far we have had the examples of the solid materials, right? The copper, aluminum, silver, etc. All of those were the solid materials through which electricity flows. But is it true that electricity flows only through the solid materials and not through the liquids? Is it true that electricity can flow through only the solid and not through the liquids?
No.
Question was, is it true that electricity can flow only through the solids and not through the liquids?
No, sir, it's false.
No, sir.
It's false, no? So there are certain liquids through which it can flow, but it depends on the type of the liquid and the presence of impurities in it. What kind of liquid this is and what kind of impurities are present in it. Getting it? That is the case. So all the liquids will also not be conducting electricity. Only certain liquids will be conducting electricity. Getting it? That is the case. Also, like liquid metals, like for example, mercury is a liquid metal now that can conduct electricity, by the way. Okay. But that doesn't mean we will replace the copper with the mercury, because it is in the liquid state, so can't be made into the wires and all that. Okay. So can liquids conduct electricity? So not all, but some can conduct electricity. Now, what is the requirement for a given liquid to behave as a conductor? Let us discuss that. Here we have got two setup, one that has water with impurities, another that is not having any impurity. That is the distilled water. So you see the difference between the two. What's the difference here? In fact, it is very obvious.
The water with impurities is able to conduct electricity and light up the bulb.
Exactly. Right? So the water that has impurity is able to conduct the electricity through it, and hence the light, the bulb is glowing up. While the other one that does not have any impurity is not lighting up the bulb. Getting it, everyone? That is the case. So you need to have some impurities in it, right? So water that we get from sources such as the tap water or the hand pump or the wells and the pond, these are not pure, but they contain some impurities in it. Getting it? They contain impurities in it right now. And the small number of mineral salts are naturally present in the water. Mineral salts are naturally present in the water. So salts of calcium, salts of magnesium are present in that water. So suppose you were to take a sample of water from the nearby pond or from the well. So that water will have some amount of dissolved mineral salts in it. Like for example, it will generally have the pond water or the well water will generally have mineral salts of calcium, or will have mineral salts of magnesium, etc. Getting it, everyone? So mineral salts are present. Example is that of calcium or that of magnesium, right? And the major component of that water is basically water only, apart from this, that it contains some mineral salts in it. So this tap water, suppose this is tap or well water, suppose tap water, it is not pure, it is impure. Why we are calling this as impure? Because this water is a solution. What is it? It is a solution. Okay, it is a solution. And solution by definition means that it will have two components in it. It will have two components. So it will have solute in it, plus it will have a solvent in it. Now, what are these terms, solute and solvent? So the substance that is present in lesser quantity, that is called as solute. So which one is the solute here? The water or the mineral salts?
Mineral salts.
Mineral salts, no? So thereby it has some solute in it. This is the solute. And thereby the water itself is present in the major quantity, in the more quantity. So thereby the water is the solvent here. Getting it, everyone, so far?
Yes, sir.
Okay, let me conclude this. Everything will be clear once I conclude this. So that is the solvent here. So solvent plus solute makes it a solution. So tap water is not pure, but it is impure since it's a solution. It has got both a solute and a solvent in it. So thereby, this tap water is impure. Let me know if this much is clear so far.
Yeah.
The
Yes,
reason
sir.
the tap water is impure since it has solutes dissolved in it, and thereby it's a solvent. Sorry, thereby it's a solution. Okay. Apart from that, there are many other things also, like bacteria and many other things would also be there in it. Okay, no? That is the case. Also, tap water is not fit for consumption. It must be treated with chemicals like chlorine to kill the microbes and fluorides present in it. If fluoride is present in the water, no, it can be it can lead to decay of the tooth also. So also, like whenever you purchase a toothpaste, make sure the fluorides are not present. It is free from fluoride, because that can lead to tooth decay. Anyways, so what can we conclude from this discussion? That a liquid that has impurities in it, certain liquids that have impurities in it will conduct electricity. So certain liquids with impurities conducts electricity and will split into its components upon passage of electric current through it, upon passage of current through it. Take a very simple example, like take example of acid water. Suppose acid water, will you call this pure water?
No.
No, right? So suppose we have taken sulfuric acid in water. We have taken sulfuric acid. Sulfuric acid is a strong or a weak acid? What do you guys say?
Strong.
The strong
acid.
acid.
Good. So it's a strong acid. Can I call this as a mineral acid? We can call this mineral acid, no? So when the current will pass through it, so the water here is going to split up into hydrogen and oxygen. So this acid water is an electrolyte. What is it? It is an electrolyte. Okay. So how do we define an electrolyte? How can you define it? Basically, it's a substance in the liquid state that breaks apart into its component when electricity is passed through it. Got it, everyone, so far? And in the case of the water,
sir.
particularly this example, hydrogen is going to be the positively charged particle into which it will break. Oxygen is going to be the negatively charged particle into which it is going to break. Later on, we are going to revise about these. Can anyone let me know what are we calling these charged particles? These charged particles, what do we call that?
Cations and anions.
Exactly. They are called as ions, respectively. They are cations and anions. The positively charged particles were cations. The negatively is anions, right? So the components here are basically the ions into which it is splitting up. That is what the component here is being referred to, that certain liquids with impurities conduct electricity and will split into its components. So components were basically the cations and anions into which it will split up. So the definition for electrolyte will be that it is a substance, particularly in the liquid state, that will break into its components, that is into ions, when electricity passes through it. Okay, hope it should be clear. Take a look at some of the given liquids here. These are the different materials under the test, meaning that if I were to replace this water, for example, with these given samples, okay, see how it will be behaving. Like, will it be a good or poor conductor? So distilled water, it is going to be a poor conductor. Okay. Tap water, good conductor. Why? Why the tap water will be good conductor?
Because it has impurity.
Exactly. It has impurities. It has mineral salts, bacteria, etc. in it. Lemon juice,
It has impurities.
it's a good conductor. Then vinegar is a poor conductor, right? Okay. So also keep in mind that although vinegar is impure, it has water as well as acid in it, but it is not necessary that just by being impure, it will behave as a electrolyte. That's why I have written here that certain liquids with impurities, not all of them. Because if it will be any liquid, like for example, vegetable oils also have impurities in it now. The cooking oils, getting it. Particularly this one, the fuel oil, I mean to say. The fuel oils like the petrol, like the diesel and the kerosene, they also have impurities in it, but that doesn't make it a good conductor. So only certain liquids with impurities will conduct electricity through it. So cooking oil is a good conductor, milk then is a good conductor, honey is a bad conductor, although has lots of impurities in it. Getting it, then the different soda compounds or the mercury, they are good conductor. Hope it should be clear so far. Okay. Harim, read the given paragraph.
How do liquids conduct electricity? Liquids conduct electricity if they contain ions, charged particles. If an electric current is passed through a liquid, these ions move, allowing the current to flow. Examples of liquids that conduct electricity include salt water and acid solutions, as they have free ions, while pure water do not conduct electricity well because of it lacks iron.
Okay, so the main thing here is the ions. If a given liquid produces ions, it breaks up into ions, then it will allow the flow of electricity through it. Okay, so we have salt water, we have acid solutions that will conduct electricity because they have ions in them. They will break up into ions and that will allow the conduction of electricity through it. Well, pure water does not because it lacks ions. Okay, answer these questions quickly. Everyone have to answer. Where did Vaiga go? Okay. So which part of an atom is responsible for flow of electron? Is it a proton, a flow of current, I mean? So is it the proton, electron, or is it the neutron?
Electron.
Okay. What makes distilled water a good conductor?
Impurity.
It has
Dis-
impurities. Okay.
Distilled water is pure water, right?
It is, okay, the question has been not framed correctly. 1 minute. Make a bad conductor. Okay, no? What makes distilled water a bad conductor?
Not enough impurities. Being pure.
Okay, it is not impure. It is a pure water, right? So thereby does not have any impurities. Since it is pure, so thereby has got no impurities and hence will not conduct electricity. Now, third question is the interesting one. Will the solution of sugar in distilled water conduct electricity? Interestingly, although it will become impure, but it will not conduct electricity. Okay, no? So you have the sugar solution, you have the honey, like that. So they are poor conductors. So they will not conduct electricity. Okay. The answer is no. Fourth one is normal water conduct electricity. Yeah, good, Harim, correct. Spelling is correct, incorrect for the impurity. Yeah. So normal water conducts electricity while the pure or distilled water does not. Why?
Normal water has impurities that allow to conduct electricity, while pure or distilled water don't have impurities, so they can't conduct
Hmm.
electricity.
Good, very good, right? And having impurities means that it will split up into ions. Upon passing of electric current through that liquid, that impure liquid will split up into ions, and the ions helps in the conduction of electricity. So the main thing here is the ions as well. Okay. And what are the impurities present in the normal water, like in the tap water? Yeah. What kind of impurities will be present in it? Yeah. There are different mineral salts present in the tap water, right?
Yeah,
Dust particles can also be there. Okay. So you have common minerals present in the tap water is like calcium is there, magnesium is there, huh? Potassium, sodium, etc. Now, question is like, why is it that LED bulbs are much suitable to test the electrical conductivity of the liquid here? In order to check whether this liquid is a good conductor or a bad conductor, a good electrolyte or a bad electrolyte, I will always prefer to use a LED bulb here. Why is it so? Okay, you just answer this to me. See, if you were to take an incandescent bulb, you understand the incandescent bulb, the one that has tungsten in it? Yeah. and it works on the heating effect of electric current. On the other hand, you have the LED bulb. So which one consumes more electricity? Which one needs to be supplied with more amount of electricity in order to light? Yes, Harim? On one hand, you have this LED bulb. You have this LED bulb. On the other hand, you have this incandescent bulb. Which one consumes more electricity? Obviously, the
LED bulb?
no, incandescent bulb consumes more electricity. Okay, now that's why its use has been discarded. That's one of the main reason that it is no longer used. The LED bulbs that we are using nowadays consumes lesser amount of electricity. So, but how is it related to this topic? Suppose, for example, if this is a weak electrolyte, this is a weak conductor of liquid. Okay, so even that will be spotted, that will be identified. Even if it's a weak electrolyte, it will allow a little flow of electricity through it. So even little amount of electricity, the LED bulb will glow. But in place of, if you were to replace it with the incandescent bulb, so if this weak electrolyte were to allow only few electricity, a little amount of electric current to pass through it, so that incandescent bulb would not have glown basically. Okay, now Ramesh, read the given paragraph.
LEDs, light emitting diodes, are more suitable for testing the electric conductivity of liquids because they can glow even with a very small electric current. Many liquids only allow weak current to pass through them, which might not be enough to light a normal bulb. However, an LED is sensitive and can indicate conductivity even in such cases.
Okay, so hope it should be clear. Any questions so far?
Okay.
Okay, now let us talk about this chemical effect, right? So chemical effect is defined in the following manner, that when an electric current flows through a conducting solution, so chemical reactions takes place in that solution, and this is called as the chemical effect of electric current. It is called as chemical effect of electric current. Say for example, you have a copper sulfate solution. Copper sulfate, you all have heard of this before or not? This chemical?
Yes.
So you have a copper sulfate solution, that is CuSO4. Now, when electricity will be passed through this solution, keep this in mind, we have taken a solution of this in the aqueous state. We have taken a solution of this. Okay, I have written it already. So when the electricity will be passed through it, what will happen? It will split up into two components, namely the copper and sulfate. Copper plus sulfate, copper ions and sulfate ions. So hasn't a chemical reaction happened here?
Yes,
Aren't
sir.
we getting new products forming here, right? So that is the very basis of chemical effect of electric current. So once, if this question is asked supposed to you, so you'll be writing down this definition and you can quote an example. Suppose if you forget this example, you can write the impure water. Take impure water, for example, you have added acid in it. So that will split up into hydrogen and oxygen. Okay, now hydrogen and oxygen. Got it, everyone? Now, what are some of the observations that can be made whenever a chemical effect would have taken place, like when the electric current will be made to pass through a given liquid? So depending upon the type of the electrolyte and the type of electrodes, you haven't forgotten the electrodes now, I suppose you all remember, right? The rods that will be used for the flow of electric current through it. From one of the rod, electric current will enter, and from the other one, the electric current will leave the given solution. So depending upon the type of solution, the type of electrolyte we have, and the type of the electrodes, various observations can be made. Getting it, Harim, Ibrahim, and Ramis? So one observation is that there can be a deposition of metal from one rod to another, and that one we call as electroplating. Getting it? So deposition of metals may be seen on the electrodes. If you guys were to look carefully, so you will observe that how metals are depositing from one rod to another. Observe this one. Earlier, this rod was not electroplated. It didn't had any coating of gold on it. But due to passage of electric current, the gold is getting deposited on this. All of you turn your cameras on. Harim and Ibrahim, you guys turn your camera on. Yes, Harim. In this one, what do we observe? Near the electrodes, what is your observation? Are the bubbles forming? Right?
Yes, sir.
So one such observation is that bubbles can also be evolved near the electrodes. And in this one, what is happening? We have taken a slice of potato and we have connected it with wires. So near this, we are seeing the color is changing. The color is changing and this one is becoming bluish green in color. That is turning bluish green. So hope you guys are able to understand this much, like what are the observations that can be made. Okay. So bubbles of gas may be formed, deposition of metals onto the electrodes can be observed, and they can be change of color of solution or the given material as well. Any questions?
No, sir.
Deposition of metals, then evolving of bubbles, release of bubbles basically, and thereby you have color change. Okay, now in a given reaction, it might happen that you can make two or more than two observations also. Like in some of the reactions, only deposition of metals can be happening, but simultaneously we can see that bubbles might also be forming there. So that is also the case here. Then there are various applications of this chemical effect. So we can extract the metal from the ores. You guys tell me, how do we obtain the different metals from the nature? Like, for example, you have an iron rod. Suppose I have an iron rod in my hand. So in the nature, will it be occurring in the same state, or will it be in the impure state in the form of a rock?
Impure
In the
state.
form of a
Impure state.
Yeah, in the form of a rock in the impure state. So that is called as the ore. Okay, no? So no matter whether you have iron, you have aluminum, or any given metal, all of them are extracted from their ores only. So there also, in the chemical effect, there also the chemical effect of electric current will be used. Then, if you have to purify a metal, suppose I am having a piece of copper metal, okay, but it has some impurities in it. I need to get rid of the impurities from it. So there also we can do this thing. We can apply the chemical effect. Then we can produce new compounds using chemical effect, and we can break up a given compound using this. There was one more important thing, that is we can do electroplating also. Electroplating. So first now we'll be learning about the electroplating. Okay. By the way, did we discuss regarding ions or not? Later on we will have this topic. We'll be discussing about it later on. I think we have discussed that already, by the way. Okay, let's
Yes, sir.
continue with this. So like, what is electrolysis, right? So electrolysis is basically the effect or the phenomena in which the components of a compound gets splitted up into ions when electricity passes through it. So that is called as electrolysis. Let me repeat that. It is basically the process or basically the phenomena in which the components of a given liquid, given compound, splits up into ions when electricity passes through it. For example, you have a given electrolyte here. Electrolyte is, you have given an electrolyte solution. Suppose this is again copper sulfate, right? So when electricity will be passed through this, it will split up into copper ions and sulfate ions, right? Getting it or not? So the whole process is called as electrolysis. Any questions from this? And we
No,
have
sir.
already discussed that in the case of electrolysis, depending upon the type of solution and the depending upon the type of electrodes you have, various observations can be made. Like in the case of the water, for example, you have taken an acidified water. Okay, so in that case, what will happen? Evolution of gas will occur. Gas bubbles will be forming near the electrodes. In certain cases, there will be deposition of metals on electrodes. Certain cases, there will be change of color of solution. So all of this depends upon the type of solution. I mean to say, literally, we can say type of electrolyte or the type of electrodes you have. Let's learn particularly the case of the water. Okay, one of you please read this one. Ibrahim, you read this. Release of gas bubbles on the electrodes. Please read from here.
Release of gas bubbles.
Continue.
Release of gas bubbles on the electrodes. When current is conducted through water, oxygen and hydrogen bubbles are created. On the positive electrode, oxygen bubbles will be present, whereas hydrogen bubbles will be present on the negative electrode. Chemical reaction takes place when an electric current passes through a conducting solution. As a result, gas bubbles.
Continue. Gas bubbles could form on the electrodes. See, so when the electricity will pass through it, water will split up. Okay. By the way, let me just give you a brief introduction to the electrodes also. Then we'll be discussing this particular example. Electrodes are basically the rods made up of, like basically these are the conducting rods, okay, through which electricity will be entering or leaving this electrolyte. That is what an electrodes are. The one that will be connected to the positive terminal will become the positive electrode that we call as anode. And the other one connected to the terminal of cell, the battery, that will be cathode. Got it so far, everyone? About the ions, what we generally know that, see, generally in any given atom, we have got in the nucleus, you have proton and you have got neutron. Protons are positively charged, neutrons have zero charge on them. They don't have any charge. So let's not talk about them. Let's talk about the electron here, which have got negative charges on them. So if in a given atom, the number of protons and number of electrons are equal to one another, suppose if there are 10 protons, so it will have 10 charges on it, right? 10 positive charges, and there are 10 electrons. So meaning that they have 10 negative charges. So both the charges are equal now, 10 positive, 10 negative. So then it is in the neutral state. Getting it, Harim? Getting it, Ramis and Ibrahim?
Yes, sir.
But suppose if if it were to lose some electrons, now suppose the number of electrons is 9 only, but the number of proton is same. So thereby it has 10 protons but 9 electrons. So meaning that it has 10 positive charges, but it has now 9 negative charges, which is unequal. So in this case, there is a loss of electron. Electron is being lost now. So what is the overall charge, the net charge?
One positive charge.
Exactly. Right now, the difference you will calculate, there is one extra positive charge. So thereby, this atom will be now called as cation. It is not a different thing. It is still an atom. It has one or more than like could be having uh, one less electron, or could be having two less electron or more than that. So it has less electrons in it. So thereby, it is positive. And suppose if it were to gain some electrons now, then what happens? Suppose if it now increases to 11 electrons. Earlier it has 10 proton. So again they are unequal. So there is one extra negative charge in it, right? Right or no?
Yeah.
So when it gains electron, it becomes negatively charged. So that is the ions. So ions, they are the charged particles formed due to loss or gain of electrons. Hope it should be clear. If it lost, what will we call this? And if it gains, what do we call this ion? Tell me.
Loss is
Yes, Ramesh. Yes, Harim. If an atom is losing the electron, what do we call that? Take a look at this. Yes,
Cation.
Ibrahim. Cations, no? Good. So cations are positive, okay, now? While the opposite is
Anion. Anion.
that a negative charge. Okay. So that is all about ions. Hope it should be clear to everyone, okay? All right. Let's continue with this now. So in this, what we were learning that when electric current is made to pass through this wire, sorry, through this water. By the way, this water has to be impure. Okay, now you know that it has to be impure. So it will split up. It will split up into hydrogen ions, and the next one will be the oxygen ions, right? Always keep this in mind. The first ion is always positive. By convention, you should memorize this thing that the first one will always be positive. So that one will be cation. Another one will be anion, okay? Now you also know about the electrodes so far. So the one that is connected to the positive terminal of the battery, what do we call that? Yes, Ramiz? Ibrahim? Yes, Harim? That's the anode now. Very good. So you guys tell me, anode will attract which ion? The one which positive charges or one that is negative?
Negative?
That's negative exactly. So anode will attract anions. So anions in this case is which one? The oxygen ions or the hydrogen?
Oxygen.
Very good. So these bubbles are of oxygen. So these are the oxygen bubbles. And the one that is connected to negative terminal, so that one is the cathode. And it is obvious that it will attract the
Cation.
yes, cations. In this case, it is the hydrogen.
Hydrogen.
Very good. So hope that much should have been clear to everyone.
Yes, sir.
Yeah. Okay, if there's even a slightest doubt, please get it cleared.
No, doctor.
Okay. So that was it. Okay, then in the later classes, we will learn about the electroplating particularly. That is also an example of chemical effect. And let us just discuss one small topic, okay? Like why we would be doing electroplating. We know that it's a very useful process and lots of materials are coated with a layer of other metals on it. Like for example, as we know about iron. Iron is very reactive towards oxygen and water. No? It reacts with the damp air and develops a layer of rust forms on the iron. Okay. By the way, okay. So in order to protect the rusting of the iron, we have various methods like we will be first, sometimes we'll be using sandpaper to scrape off the rust. Sometimes we have to apply a layer of paint above it. Then sometimes we need to do a coating of zinc on it also in a process called as galvanization. So there it is helpful. We can improve the longevity, we can improve the durability of the iron objects. Why galvanization, isn't it? So one such reason would be to protect the corrosion of a given object and improve its durability, right? Then we see that the door, like for example, the door handles of the cars, and the kitchen utensils, the bathroom taps, all of them have one thing in common, that all of them are having a shiny appearance, right? We have certain metals which are very shiny. For example, chromium is a very shiny metal, but it's a costly metal also, right? So the whole object cannot be made up of chromium since it is costly. So we just apply a thin coating of chromium on these objects, like as you can see here. So there it is important to get a shiny appearance. Getting it, everyone? So these topics we'll be doing in the next class. By the way, Hari might have told you in the previous class to send me the list of the topics from those chapters which are coming in your exam. Particularly, if I can recall, you had some of the chapters like it was like water and carbon and like that.
Yeah. Oh, my bad. I forgot to send.
So
I'll
try
send it
to,
after class.
yeah, make sure to share it. Okay.
Okay.
Okay then, guys. That's it for today's class. Allah Hafiz, everyone.